right, so the control variable is what I would say is the normal. It's the normal, okay? What would happen if you never did the experiments? That's another way to think of this. What would happen if I was never doing any experiment, okay? That's your control, the normal. It shouldn't have anything change, so it just should be the normal circumstances with no changes, okay? And it's not being tested anyway. It's simply used to compare. The key words, in my opinion, here are normal and compare. So what would happen in normal everyday life if I never did my experiment? And then when you do the experiment and you change things on purpose, you will always compare those back to the control. How fast did this go compared to the control? How long was this compared to the control? How many centimeters compared to the control? You're always comparing back to the control. Does that make sense? So if I was the control, you're like, how tall am I compared to Mr. Pilcher? All of you, the answer would be short. But anyways, it just depends what you're comparing back to. So that's that. The dependent variable is what is being measured or observed, okay? What are you measuring? What are you observing? What are you looking at in the experiment, okay? What are you looking at in the experiment? That is what is the dependent variable. And you should always plot that puppy if we're going to be doing graphing later this week. So just a reminder, the dependent variable always goes on the y-axis. That's the tall one, the vertical one. I always remember from elementary school, the letter y is taller than the letter x, so that's the tall axis, the one going up and down. It's funny the goofy things that end up sticking in your brain for whatever reason. Alrighty. The independent variable, that's what you are testing. That's what you are testing. Again, that's that key word there, testing. That's what you are testing, okay? You are purposefully adjusting the independent variable, okay? That's something that you are purposefully testing. You are adjusting in some fashion. And then you want to see what happens to the dependent variable. The dependent variable depends on the independent variable. So you make a change on purpose in the independent variable, and they're like, now what did that do to my dependent variable? The independent should always be placed on that horizontal axis, the x-axis. So when you guys are doing graphs later this week, independent always goes on the x-axis. Dependent will always go on the y-axis. So now that brings us to some practice problems. This very first one about Mr. Pilcher drinking, or not me drinking, having my students drink Monster Energy drinks. Let's go ahead and put 60 seconds on the clock. I want you guys to just read through that paragraph, get a feel for what this experiment was about, and then we'll talk about it. So you guys spent a few seconds here reading through this. All right, the basic idea is that I'm like, all right, I want to see if I can help my students' productivity. So I'm like, all right, if I give them Monster, I bet they're much more productive. So I got a couple of classes of 30 students in each class. So I want them to write down the phrase chemistry rocks as many times as they can. Okay, so that's how I'm going to measure how productive they are. How many times they write down chemistry rocks. So class A, I gave them a bunch of Monster. Class B, I didn't give them anything to drink. And after an hour, I was like, all right, Class A, how many times did you copy this? 1,500 sometimes. Class B, 2,100 sometimes. Alrighty. You can talk to me about the control group. Which one's our control group in this particular one? Yes, sir.
Group B.
Group B, how do you know that?
Because nothing was changed with them.
Right. If I never did this experiment, Group B would have still had the exact same experience. Does that make sense? They are the normal. They are the normal. Nothing has changed with Group B. I don't usually give Monster. They didn't get a Monster. Like, it might as well have been a normal day in class. Like, okay, yeah, that's writing chemistry rocks. You got it. Independent variable! What we got? What was that in this particular experiment? Let's see, I want another paw. Ooh, yeah, there we go. The Monster drink, right? So, the Monster Energy drink. I purposefully adjusted how much Monster people were getting. I was like, all right, Jameson, your class gets a can of Monster. is that your class does not get a can of Monster. I chose that change before the experiment even started. Okay, I knew what that change was going to be before I even started the experiment. Monster Energy drink. Some people could have written amount of Monster here as well. Okay, you don't have to have these exact words. The dependent variable. Who's got me? Talk to me. Dependent variable. Mr. Workman, what we got? Group A. Why do you say that? Oh, I see what you're thinking. Okay, like so that's what we're testing, but that'd be more about like the independent variable if we're talking about what we're testing. Remember, the dependent is we're looking for what was being measured or observed. What was the thing being measured or observed? Jameson?
Number of times chemistry rocks.
Yeah. How many times they wrote chemistry rocks, or their productivity? In this case, we're calling their productivity how many times they write chemistry rocks. Yep. There we go. Now, forgot this part. Should he is... We're talking about me. You guys can tell I stole this worksheet from Ms. Bay. She's got good worksheets. Teachers are notorious thieves for good worksheets. Somebody's got something good, we'll steal it. No shame in that. In teaching, anyways. Now, should I accept this hypothesis or not that Monster Energy drinks help productivity? I see in your head shake no. Why is that? I like that. I like that you're specifically pointing to the data. Like, okay, Group B wrote more, and they didn't have a monster, so that actually disproves your hypothesis. So you should definitely reject it because less of the task was done. Productivity was decreased when you had a monster. Mr. P, do I have to write that exactly like you have it? No. You just have to make sure it's clear you understand that it should be rejected and why. And as I specifically mentioned, the decrease in productivity. Okay. Any thoughts on how we could maybe improve this experiment, though? There's many right answers to this. Any thoughts? Yeah, Zach, what you got?
Do with more classes.
Why would more classes be better?
Because maybe Group B is just way more focused all the time instead of Group A. Maybe just Group A was lazy, so you need more classes.
Right. What if Group B is like third or fourth period in the day, but Group A is like right after lunch, where you're sort of in that food coma, okay? Maybe that's the problem, right? So if you get more classes, okay, then your data is a little bit stronger. More data points gives you a little bit stronger data. So that's good. I love that. What else we got? Yeah.
Giving the monster to them before they wrote, so they wouldn't have to drink it instead of writing.
Oh, okay. I like that too. So like, all right, well, what if like just the act of drinking monster was slowing them down? Okay, so maybe you should give them the monster before the like timer starts for productivity. I like that idea. That's good too. What else we got? Anything. If you're not sure if it improved it or not, you can just throw something out there and we can discuss it. What we got? Skurlock, give me something. That's all right. You got something over here?
Having the same student do it.
Having the same student. Okay, so maybe instead of having two different classes, maybe we should have the exact same class do it, right? Okay, that's not a bad idea. This is a question you guys should always consider at the end of a lab. Like, if you did this again, how would you improve it? What would you do differently? What didn't go so well? That kind of thing. Reflection questions on like how we want to step up our game for next time, so we can be ever increasing our abilities to do experiments. These I'm going to reveal right here. You should not feel like you have to write down all these. These are just some things that popped up in my head while I was typing this up, okay? So stuff like you could change the task. Is writing down chemistry rocks really like a sign of productivity? Whether it's more about how fast people can just write in general. Like I wouldn't consider, like if Abby sat there and just wrote chemistry rocks over and over again all period long, I would not be like, she learned something today. She was productive today. I'm like, she did nothing today. Okay? I wouldn't really consider that's not productivity, so maybe we should change the task. Larger sample size, we talked about that. More or less monster, maybe like a little cup of monster has one effect, but a whole can has another. Because maybe it's, whoever was mentioning that, maybe it takes a while to just drink the monster, and that's what's slowing them down. Monster delivery system, okay. Do we want to find an easy way to get people to drink the monster? Who can say? Again, there are so many possibilities on this one. It's always good to reflect. It's always good to reflect. So at this point, you guys have several more practice problems here. If you are at home watching this video, the answer key to this video is right below it. If you're here in person, it's on your desk right in front of you. Why don't we just put a few more minutes on the clock, see if you can knock out one or two more of these, and then we're going to get started on our lab. If you're at home, you're all good for a lecture today. Go ahead and wrap up this worksheet. Let me know if you have any questions.